AI about AI. I've taken to talking to AI in the car, dialing back the playlists and podcasts. We work through ideas on business, my art, and realistic and sometimes far-reaching AI use cases. Today, we're talking about RAG, or Retrieval-Augmented Generation, and how it is used to find information with AI language models. If you're wondering, this is my actual conversation with a chatbot, where we verbally talk back and forth. What you're listening to is a slimmed down transcript just to cut down on the time, but it is the actual discussion then fed through text-to-voice AI to generate what you're hearing. This is my clone voice and a completely made-up collaborator voice.
And that would be me. I'm glad to be here.
Okay, let's jump in. Help me out here. How would you define RAG in terms of AI in very simple terms?
RAG, or Retrieval-Augmented Generation, is a method used in AI where the system finds relevant information from a large database and then uses it to help generate a response. For example, imagine you ask an AI about the best ways to care for a houseplant. The AI using RAG would first search for reliable information about houseplant care and then use that info to give you a detailed and accurate answer.
In that example, how is that different than just simply asking a language model directly? How does RAG improve that?
When you ask a standard language model about houseplant care, it generates an answer based solely on what it was trained on, which is a fixed set of data from the past. But with RAG, the AI still uses its training, but it also actively searches a large, up-to-date database for the latest information on houseplant care. This means RAG can provide more current, detailed, and sometimes more accurate answers, especially for questions where new information is constantly emerging. Oh, it's like the difference between asking a well-read friend versus a friend who looks up the most current information before answering.
Okay, so it may have more current information. Got it. I keep hearing about embeddings when people talk about RAG. What are embeddings, and what do they have to do with RAG?
Embeddings play a crucial role in how RAG works. In simple terms, embeddings are words or phrases converted into numerical values that a computer can understand. A computer can use these numeric values to determine if two different words or phrases have similar meanings or how closely they may be related. For example, fern and Ethereum niponicum, a type of fern, could be determined to be closely related. Fern and tulip would be less closely related but more related than fern and pony. Likewise, Ethereum, niponicum, and tulip may not be similarly related to fern but may both be closely related to the word plant. Embeddings are the numeric values that make that search work.
So are embeddings and RAG always used together, or can you use either one of them without the other?
Embeddings are a fundamental part of many AI models, not just RAG. They're used to understand and process language in a way computers can work with. So you'll find embeddings used in all sorts of language models, not just those with RAG. RAG, on the other hand, is a specific method that is primarily concerned with adding information to what is already in the base language model. Embeddings are used to look up information, whether it is in the RAG data or the base A model.
Can you use RAG without embeddings?
Using RAG without embeddings would be quite challenging and likely inefficient. Without embeddings, RAG would struggle to effectively search and match relevant data from its database. Embeddings allow for quick and accurate comparison of meanings and contexts. Without this, RAG would have to rely on less efficient and potentially less accurate methods of matching queries with information.
Are embeddings and RAG specific to language models, or can it be used for other kinds of models?
No, they are not limited to language models. And for example, in computer vision, embeddings help image recognition tasks by converting images into numerical representations to find images that are the same color, the same type of animal, or match accessories with specific clothes. In recommendation systems, embeddings represent user preferences or product features to suggest relevant items. And in music analysis, embeddings can represent different aspects of music, helping in tasks like genre classification or recommendations. And RAG follows suit. RAG would be the method of storing and retrieving the additional image recommendation or music information that those embeddings would be used with.
You mentioned language models versus recommendation models. A recommendation model still returns words, but they're just specific to some product or domain-specific information. Would this not be considered a language model? How do you define a language model versus something that may be based in words, but is specific to a given domain?
To differentiate, it's key to understand what a language model is and how domain-specific applications might vary. A language model is a type of AI that's trained on a wide range of text data to understand and generate human language. It's not specific to any one field. It does have a lot of information stored in it, but it's primarily trained on understanding the rules of language, not just as a data store of information. When you apply a language model to specific domains like medical journals or legal advice, you're essentially specializing it. These domain-specific applications still use the core capabilities of a language model, understanding and generating text, but they're educated on specific knowledge from those fields.
What about other non-language applications like, I don't know, chemical compounds, mathematical formulas, and things like that? Would that still be considered a language model that's trained on a specific set of information, or is it fundamentally a different kind of a model, not based on language but other non-text information?
And when it comes to applications like analyzing chemical compounds or mathematical formulas, the nature of the model can differ significantly from traditional language models depending on how they're used and the type of data they process. Models working with chemical compounds might not be traditional language models if they primarily deal with the chemical structures, properties, or reactions in a non-textual format. However, if the model interprets and generates textual descriptions or explanations about these compounds, it leans more toward a language model specialized in chemistry. Similarly, models dealing with mathematical formulas could be distinct from language models if they focus on solving, manipulating, or visualizing these formulas as numerical or symbolic data. But if the model's task is to interpret, explain, or generate text about these formulas, then it's more akin to a language model specialized in mathematics. And thus, since whether these are considered language models or not depends on whether the primary focus is on processing and generating text or data in non-textual formats.
Okay, so let me try to see if I can reflect this back using a different example. If you had, let's say, telemetry data for vehicles on a set of roads as well as data on traffic lights and traffic signs. You know, when a red light occurs or where an intersection has one or more stop signs, and you want to play with different settings to analyze traffic loads, like setting particular street light to stay red for more or less time, or try to optimize the amount of flow over a certain time period, that might not be considered a language model if the output is really just generating new telemetry data. But if you wanted to ask it questions about how to make it more efficient, what happens if there's an accident, what happens with certain weather, that might be a language model that simply has been fine-tuned to that particular use case. Is that fair to say?
Yes, your understanding is on point. If you're using telemetry data analysis to gather more telemetry data, for example, if you were to stream the output back into a simulator or a spreadsheet to crunch numbers, then that is not likely a language model. It's more of a traffic simulation or optimization model. However, if you want to ask questions and expect a textual explanation or suggestion, that's where a language model comes into play.
Let's say you built a simulator for this particular example, some sort of user interface, a web interface or an application that allows you to modify configurations, like set the number of minutes a light stays in a given state. Maybe you could add or remove stop signs at an intersection, configure weather conditions, time of day, all that stuff. But you can also ask questions like, what times during a typical weekday is it most likely that the travel time along this route would take longer than 30 minutes? Using both language and the simulation. Is it best to have two different models, or could one model work for both?
In the scenario you've described, it's generally more effective to use two separate models, each specialized in its own domain. Having two distinct models allows each to be highly specialized and effective in its area. The simulation model can focus on accurate and complex data processing and simulation tasks, while the language model can focus on understanding and generating human language. However, it's worth noting that these models would likely need to be integrated in a way that allows them to communicate effectively. The language model might need to understand the parameters and capabilities of the simulation model to ask the right questions or interpret its data correctly. This integration is key to creating a seamless user experience where you can interact naturally with the system and get meaningful responses.
You mentioned training a language model for a given domain. For example, medical domain, medical journals, or legal advice. You used the term training. Would you consider that training a model, as you said, or wouldn't it be fine-tuning a model? How would you differentiate the two?
As these terms, training and fine-tuning are related but distinct processes in AI, and the distinction is important. Training builds models with large, diverse data sets to develop basic understanding, while fine-tuning refines this model with domain-specific data, enhancing its expertise in that area. So fine-tuning just a general purpose model to be more adept in specific fields, maintaining broad capabilities while gaining specialized skills. When adapting a language model to specific domains like medical or legal, it's more accurate to say the model is being fine-tuned. This means you're starting with a general purpose language model and refining it to be more effective in a particular area of expertise. Fine-tuning allows the model to retain its broad language capabilities while becoming more skilled in a specific field.
Can you layer fine-tuned models? For example, assume the legal domain. You have a language model that has been fine-tuned it to legal cases. Maybe it has a vast amount of information on cases over the last 100 years across a lot of domains. And then you want to fine-tune it to a particular industry, say real estate, and then additionally fine-tune it to specific information in a given jurisdiction, like North Carolina, and then maybe even fine-tune it further for cases in the last year. Can you do something like that?
Yes, you can layer fine-tuning on models, progressively specializing them further. This process is often used to create highly specialized models in complex domains. Each layer of fine-tuning makes the model more specialized. However, there are a few considerations. Each fine-tuning stage requires high-quality, relevant data. The more specific the domain, the harder it might be to find sufficient data. Also, a risk that the model becomes too specialized. This is referred to as overfitting. Finally, maintenance. Fine-tuning does take effort and time. Constant updates to keep things current can be effortful and costly. Layered fine-tuning creates highly tailored models that are experts in very specific domains, which can be incredibly valuable, but does have some considerations.
Does fine-tuning favor more recent information or take precedence over older data? And would it be better to fine-tune the original model on both last year's and this year's information? Would that make any difference?
When you re-fine-tune a model on new data, how the model integrates this with the previous data depends on how it was fine-tuned. Typically, the new data tends to have more influence, so this prioritizes recent information, which might be desirable in fields where the latest information is crucial. However, if the re-fine-tuning process is balanced on both old and new data at the same time, the model might retain a good understanding of all information. So, in essence, re-fine-tuning a model on new information is a good approach if the most recent data is significantly more important. Fine-tuning with both last year's and this year's data can offer a more balanced understanding of both periods.
So let's get back to RAG. When is it ideal to use RAG instead of fine-tuning a model? So in the case of this legal domain, would it be better to fine-tune a model on last year's legal cases or use RAG on last year's legal cases?
Choosing between RAG and fine-tuning a model depends on the specific requirements and constraints of your application. It may come down to what is more important, depth versus currency. Fine-tuning on last year's legal cases is ideal when you need the model to have an in-depth understanding of that specific data set. However, the model's knowledge is limited to what was available up to the point of fine-tuning and might become outdated unless regularly updated. But RAG would be suitable if you want the model to generate responses informed by the latest available information, which might include last year's legal cases as well as any new developments up to the present moment. RAG's ability to pull in real-time data makes it great for applications where having the most current information is crucial.
So fine-tuned models can provide more depth, but RAG-enabled models are easy to keep current with information, but may not be able to address more nuanced requests, right?
Essentially, yes. A fine-tuned model may be able to answer more abstract questions of the data or find more nuanced patterns in the information. Some applications of AI only need to retrieve information and require the most current information. RAG is great for that. Now, other applications of require in-depth knowledge of the information and may ask some fairly obscure questions of it or want the AI to find hard-to-find patterns. That's more appropriate for fine-tuning.
How long does it take to fine-tune a model compared to using RAG? It seems a fine-tuned model provides richer information. I'm assuming the time, effort, or cost to continuously fine-tune a model has an impact on deciding to use RAG or not for cases where you may be on the fence about how the data might be used in an AI context.
Fine-tuning can take quite a bit of time. It depends on how big your model is and how much data you're working with. Sometimes it might just be, a few hours, but it could also stretch out over several days. And it's not just about time. Fine-tuning also needs a good amount of effort and resources, especially if you're dealing with large models or complex data. For RAG, setting it up initially can be a bit of a lengthy process, but once you've got that up and running, updating it with new information isn't too much of a hassle. It's more about maintaining your database and making sure it's got the latest info.
You mentioned when fine-tuning and refine-tuning that there is a recency factor to account for. Does RAG, like fine-tuning, prioritize more recent information when regularly updated?
RAG can indeed reflect the recency of information in its responses. However, RAG responses are more a function of relevance to the query rather than an inherent bias towards newer data. This makes RAG quite versatile, as it can adapt to different requirements regarding the balance between recency and historical data.
Okay, so let me give you an example to make sure I understand this. Let's consider the question, what ice cream flavors do people like? This question isn't about priority or favorites. It's just, what do people like? So at one point, vanilla is mentioned and added into the data RAG uses. Maybe there are other flavors as well. But vanilla is in the list. Every week, this information is updated. And at some point, several iterations later, pistachio is added for the first time to the list. It sounds like I can set this up so it prefers recency or not, right? I can configure my RAG setup so that when somebody asks again, what do people like? It favors recent information and might come back with people like pistachio more often than people like vanilla. Or I can set it up so that they're equally balanced. So maybe there's a 50-50 shot that it'll come back with vanilla or pistachio because there's nothing else to suggest people like one more than the other. It sounds like I could set it up to function with recency in mind or without. Is that a fair example?
Your example captures the essence of how RAG can handle information with varying degrees of recency. If the RAG system is configured to prioritize recent information, then when asked about popular ice cream flavors, it might indeed favor pistachio if it's a more recent addition to the database. On the other hand, if the RAG system is set up to treat all information equally, regardless of when it was added, then both vanilla and pistachio would have an equal chance of being mentioned in response to the query. The actual response also depends on other factors, such as the frequency of mentions in the database. If vanilla is mentioned far more often historically, it might still come up more frequently, and the specific way the query is phrased.
You bring up an interesting point that the amount of times data that shows up in the RAG database might have an impact, and depending on your application, this might be desired or not. In our ice cream example, vanilla might be added week after week, but some flavors just pop up every so often. I assume since I can configure how it treats data, I suppose I can also set it up to only treat flavors as unique entries. So if vanilla was added 52 times a year, but pistachio only showed 3 times, both are considered equally.
Yes, that's a correct understanding of how frequency of data in the RAG database can influence the outcomes and how you can choose to handle this aspect, either favoring frequency in the data or as unique data points. But the choice between these approaches depends on the specific goals and assumptions of your application. This flexibility allows RAG to be adapted to different applications and interpretive frameworks, depending on how you want it to weigh and respond to the data it retrieves.
Is there a standard way of defining these things, regardless of what you're using to store your information or what language models you're using, or is it going to be very specific to the environment that you're using?
The configuration and handling of data in a RAG setup can vary depending on specific tools and environments used. There isn't a universal standard for defining these aspects, as different systems might have different capabilities and methods for managing data and queries.
Give me some examples of different RAG environments so I understand what that might look like.
There are several examples of different environments where RAG might be implemented. Here's some examples. If you're using a language model like GPT-3 in conjunction with a custom-built database for RAG, you might have significant flexibility in configuring how the model interacts with the database. For instance, you could program it to weigh recent data more heavily or to treat repeated entries differently. In a setup using Elasticsearch, which is a search engine, with BERT, which is a language model, for RAG, the configuration options would be tied to Elasticsearch's capabilities. Elasticsearch allows for complex query formulations and can be tuned to prioritize certain types of data like more recent entries. BERT would then generate responses based on the search results. In a fully custom AI solution where you have control over both the language model and the data retrieval system, you could develop very specific rules for data handling and query processing. This might involve advanced algorithms for determining the relevance and weighting of data. Of course, when using cloud-based AI services like Google Cloud or Amazon solutions, your configuration options would depend on the tools and settings provided by the cloud service. In each of these environments, the approach to handling data frequency, recency, and query processing in a RAG setup can differ. Each choice of environment will often depend on factors like the specific requirements of your application, the scale of data you're working with, the level of customization you need, and the resources, both technical and financial, available to you.
Thanks, I really appreciate it. This has been very helpful.
You're welcome. I'm glad to hear you found the information helpful. If you have more questions in the future, whether about AI or anything else, feel free to ask. Have a great day.
All right. That wraps up our deep dive into RAG and how it interacts with AI language models, alongside some insightful discussions on fine-tuning models, embeddings, and more. It's fascinating how these technologies are shaping our understanding and use of AI in various domains, from legal cases to traffic management and beyond. I hope this conversation has shed some light on these complex yet intriguing aspects of AI. Remember, the field is always evolving, so there's always something new to explore and understand. Thanks for joining us on this journey through the AI landscape. If you've enjoyed our discussion and want to keep up with more content like this, don't forget to like and subscribe to the podcast. Your support really helps us keep these conversations going. Until next time, keep exploring AI, keep questioning, and keep innovating. Take care, friends.